Good evening. This is the relearning for the second standard on the most recent test, the law of conservation of momentum. So go ahead and fill in your worksheet that you should have received from me in class. The two key definitions here are that the law of conservation of momentum is that the momentum of an object will not change unless an outside force acts upon it. Remember, this is a science law, so it is not ever broken. The momentum then is an object's resistance to slowing, stopping, or speeding up, and the two parts are mass and velocity. So as we look at this and we look at your test, it's important to remember that the law of physics cannot be broken. But that is not an acceptable answer if I ask you, here's the situation, is this breaking the law of conservation of momentum? If you say no, because laws can't be broken, then I say, okay, do you understand what's happening in physics right now in this situation? What forces are acting? What are we looking at? We have to understand the why. Also, if you see the word violate, does this violate the law of momentum? That would be a word that you would see, it means break in that situation. So an example might be like this. If you fall from a treehouse, you'll continuously gain momentum as you fall to the ground below. So you're gaining momentum, you're changing momentum, but doesn't this break the law if you cannot change the amount of momentum? Well, it doesn't, because we know that laws can't be broken. So what's the physics happening? Well, the physics that's happening is that gravity is pulling on you. It is the outside force. So the law is unbroken. We're good. We're okay. So if it looks like it's broken, you need to find that outside force, the force that is acting on the object from outside of the system. Couple tips as you solve these problems. When two things collide, their momentum gets added up. The big thing is if those things are going in opposite directions, it's as if one was a negative number. So in opposite direction, momentums are going to cancel out. You have to subtract to find the new momentum. And then if things are going in the same direction, those momentums are going to add up. If one object is not moving, the final momentum is going to be the total of the one who is moving. Here's some tips for solving multi-step collision problems. First, solve for whatever you can figure out. Can you find out the original momentum? If two things are running into each other, you need to add up those masses. So it should say if they stick together. Then you need to find the total momentum. So again, if there's one object not moving, it's the momentum of the one that is moving. If there are two objects moving but in opposite directions, you have to find the difference. It's as if one was negative because they're moving in the opposite direction. Lastly, use the total momentum and the total mass to calculate the new speed, that final momentum and the final mass. Now you're going to run into at least one explosion problem. In explosions, the object's original momentums are zero because nothing's moving. The final momentum then also has to be zero, but that's because the two momentums of each pieces, they're equal but opposite. They're canceling out. Find the momentum of the piece you can find and use that momentum and the other's mass to calculate the speed. So let's look at a few of these. We're going to start with 3 from the test. I'm going to open up my doc cam here. So we've got a roller skating granny, and she's running into her grandson. Before they collide, she's moving at 7 meters per second. So we're going to take a minute and write down before and after. So this is number 18. So the granny, it has a mass of 50 kilograms and the kiddo's mass is 10 kilograms. So we've got Granny, her mass is 50 kilograms. Her velocity before the crash is 7 meters per second. Oops, excuse me. And we don't know her momentum. The grandson, I'm going to put K for kid. His mass is 10 kilograms. Velocity is 0. He is not moving before the crash. And so his momentum is 0. So I'm going to look first of all, what am I missing? Well, I don't know the Granny's momentum. So P equals M times V, and I'm going to open up my calculator, and I'm going to take 50 and multiply it by 7, and that gives me a momentum of 350 kilogram meters per second. Now, I know that the total momentum is 350 plus 0, because it says in my notes I need to add up the total momentum. So after, the momentum over here is 350 plus 0, and that's just 350 kilograms meters per second. Now, what are we looking for? We're looking for their speed after the collision. We do not know their speed yet, but we do know their mass because she's going to pick him up. Now, it might not be clear from the words. The picture is pretty clear. He's not moving. She's moving. She picks him up. And if I pick up 10 pounds, I weigh 10 more pounds than I do. So if she's 50 kilograms and he's 10 kilograms, their total mass is 60 kilograms. Now we can solve for velocity. Velocity equals momentum divided by mass. So we take 350 kilogram meters per second and divide it by 60 kilograms. And we open up our calculator, 350 divided by 60, and we get a large repeating number. But this is science, and that's okay. Sometimes numbers in science are ugly. So the answer is 5.83 meters per second. I'm going to circle that or put a box around it. So this would be the case where the object, one object is moving and one object is not. We're next going to look at an object where we have two objects moving opposite directions. Now, if I look at my notes, it tells me that I need to subtract their momentums because they're moving in opposite directions. So I'm going to write 19. And it says, during a football game, a 45 kilogram running back moving downfield with a speed of 8 meters per second runs head on with a 70 kilogram lineman moving upfield with a speed of 4 meters per second. So I'm going to take I'm going to piece it up. So again, we've got before, so written at the top, and we've got after. So I'm going to put R for running back. We know his mass is 45 kilograms. His speed is 8 meters per second, and we do not know his momentum. We know that the lineman has a mass of 70 kilograms, and he has a velocity of 4 meters per second. We don't know the momentum, but we can calculate the momentum of each of these guys. So we're going to do that right now and fill it in. So I've got 45 times 8 gives me 360 kilogram meters per second for my running back. And I've got 70 times 4, which gives me 280 kilogram meters per second for my lineman. Now, one's going this way, one's going that way. and so they're going to cancel out. So in order to find the total, we actually need to take total. We're going to take 360 minus 280. And we end up with the momentum after the crash is 80 kilogram meters per second because they're going in the opposite directions, and so their momentums cancel out. Now, let's go back. Are we going to add up the momentum, or is just one thing moving? Nope, the two players collide and stick together. One's tackling the other, they're holding on to one another. And so they're going to move together. And so if they're moving together, we need to add their masses. And when we add 45 to 70, we get 115 kilograms. Now we are looking for the speed, but we can now find the speed. Speed equals momentum divided by mass, which I put too many bubbles on. There we go. We've got 80 kilogram meters per second divided by 115 kilograms. Opening up we got 80 divided by 115. It gives us 0.695, blah, blah, blah. But I'm going to just round it to 0.7 meters per second. And I'm going to put a box around my answer, which you should do as well. Last but not least, we have an explosion question. This will be question number 20. A 2,400 kilogram cannon shoots a cannonball. The cannonball's mass is 7 kilograms and it moves at a rate of 375 meters per second when it is shot. How fast does the cannon move after it shoots the cannonball? For this one, I'm going to draw a really bad picture. So we've got our cannon and we've got our cannonball. And the cannon's moving this way and the cannonball's moving that way, but they have equal and opposite momentums. So I'm going to write mass and velocity under the cannon, and I'm going to write mass and velocity under the word ball because my cannonball's too far to the left. All right, but we're looking for, what are we looking for? We're looking for the cannon's velocity. So this is where we need to be. It says, how fast does the cannon move after it shoots the cannonball? That's what we're looking for. What do we know from the problem? We know that the cannon's mass is 2,400 kilograms. Well, we can't find the momentum yet. What else do we know? The cannonball's mass is 7 kilograms. We also know that the velocity of the cannonball is 375 meters per second. Now, we're not given the momentum of the cannonball, but we sure as heck can figure it out. So momentum equals mass times velocity. Momentum equals 7 times 375. I'm going to call up my calculator here. 7 times 375 gives us 2,625. This is momentum, so kilogram meters per second. Now, what do we know about the momentum for the cannon? Well, we know before the cannon was shot, the total momentum was 0. Nothing was moving. So what we know is that the momentum of the cannon is also 2,625 kilogram meters per second. And now we can find the speed. The speed equals momentum divided by the mass. So we take this number, 2,625, and we divide it by the mass of the cannon, and that gives us 1.09 meters per second. You can also round it to 1.1. That's how you do those problems, ladies and gentlemen. If you're still struggling, you need to come and see me. I hope this was helpful. You need to do the rest of the problems as additional practice. Once you do those, I will check the answers, and I'll see if you're ready for the retest. Good luck. Keep being gritty.